Okay, hello friends. I'm Ram Lakshmanan, architect of Ycrash. In this talk, we are going to talk about the C1, C2 compiler thread in JVM. See, the C1, C2 compiler thread, sometimes it will start to consume iCPU. You may have encountered. So if you encounter it, what are the potential solutions? What are potential resolutions to it? That's what we're going to talk about in this talk. See, friends, there are some terminologies like a Hotspot JIT, C1 compiler thread, C2 compiler thread, code cache. These terminologies used to a little bit terrify me before. So I'm going to share what those terminologies means to you in this conversation. So it may be helpful for you as part of when we try to troubleshoot the C1, C2 compiler thread, we will learn these terminologies. Okay. So what is Hotspot JIT compiler? Does anyone know what it is? Hotspot JIT compiler.
It's just-in-time compiler.
Okay, just-in-time compiler. Yeah. Do you know what does it do?
No, not in detail, but yeah.
Okay, that's fine. Okay. See, friends, the code, right? Our application code, make a very big application may contain millions of lines of code. Several application contains several thousands of lines of code. But it's not all these millions of lines of code will determine your application performance. Only a selective subset of it, which is part of the critical code path, which is part of the critical transactions, they get executed again and again and again. Just a small subset of your millions of lines of code is what gets executed again and again because of the traffic pattern, right? It's not like, even though you may have hundreds of API, maybe probably 5–10% of your API accounts for 90–95% of your traffic volume. So just that particular APIs, which gets executed most number of time, that is called as a hotspot code, right? Because that is a code which determines your application performance, a small subset, right? See, friends, the code that we write, right, in Java or in any JVM language, right, Scala, Python, or anything, it is not the actual code that gets executed at runtime. JVM, Java Virtual Machine, uses this thing called as a JIT, just-in-time compiler. Using this JIT compiler, it optimizes the code that what we write during our development time. It optimizes the code for a better performance. Like, see, the code that we write finally just gets executed as in registers, right? Those thing is heavily optimized. That optimization is done by this JIT compiler. So this is what it's called as a JIT compilation. That is from a very high level. The code that we write is not the actual code that gets executed, especially that small hotspot code gets optimized by the JVM for a better performance. So that is done by this JIT compiler. Is it making sense what I'm saying?
Yeah.
Okay. See, and then there's another terminology that what you want to be aware. It's called as a code cache. So what is code cache? See, the code that what is being optimized, right, which is being compiled for optimized execution, that is what is called as that code, what is being optimized, is stored in a region in JVM memory called as a code cache. So the code that is optimized, which is native code, which is for execution, that code is stored in a region called as a code cache. So this region of memory is outside of your JVM heap. That is, it's outside of your XMX. And then it's also outside of your metaspace, right? This is a separate region outside of these two regions. See, I'm not going to go into the details of JVM memory regions. If you want to know, there is a link which is given here. So you can look into this video clip there. I talk about different JVM memory regions. So there is this region called as code cache, which is outside of this, your heap, which is XMX and metaspace. That's where this code, where the native code compiled for optimal performance is stored. That is that code cache region. Okay. So now, what is C1 and C2 compiler threads? See, friends, historically, when JDK came, when Java came in mid 90s, 1996, when it came, there were two types of JIT compilers. There are two types of JIT compilers. One is called as a client JIT compiler, and other is called a server JIT compiler. Back in those days, when you want to download the JDK, you need to choose whether I want to download a client JIT compiler JDK or whether I want to download the server JIT compiler JDK. So what is the difference in between them? See, the client JIT compiler is the one, say suppose if you are building desktop applications, right? I'm building a desktop applications using AWT or those kind of swing, then I go for client JIT compiler. But let's say if I want to build a server-side applications, like a web applications, right? Then I go for server JIT compiler, JDK, right? See, what is the difference? What is the difference in between them? The client JIT compiler and the server JIT compiler. See, the client JIT compiler, what does it do? It starts compiling, it starts optimizing your code right when your application starts. Immediately, it starts to do the compilation, it starts to do the optimization. But the server JIT compiler, what does it do? It will not immediately, it will start doing optimizing your code. It will wait, it will observe, it will see what is the code path that is being executed, how the execution is flowing. Based on that knowledge it accumulates, it goes and then it does the optimization. It does the compilation. So the server JIT compilation, it takes time, but the code what the server JIT compiler produces is more performant at the end of the day, right? So this is the difference in between a client JIT compiler and a server JIT compiler. But in modern JDKs, what they have done is the JDK team, they have merged both the client and the server JIT compiler into one JDK. So today when I'm going to download, I'm just downloading one JDK. That JDK contains both the client JIT compiler and the server JIT compiler, right? It contains both. The JDK team members, internally they were calling the client JIT compiler as a C1 compiler. And the server JIT compiler, they were calling it as a C2 compiler, right? So the threads which is used by the client JIT compiler is called as a C1 threads, C1 compiler threads. And the threads which is used by the server JIT compiler is called as a C2 compiler threads. So modern JDK, what does it do? First, when you download and then you install, when you run the application, first your code is compiled by the C1, that is a client JIT compiler. And then as time progresses, then the code is optimized and then it's compiled by the server, that is a C2 compiler, right? So that's how it works. So this is the C1 compiler threads and the C2 compiler threads. Do you guys have any questions so far? Okay, so I assume there is no question, so I am progressing. See, what is the default size of the C1 and C2 compiler threads? See, it is determined based on the number of CPUs that is available, right? So say if you're running with, let's say you have 4 CPUs, you're running on a device which has 4 CPUs, then one thread is allocated for your C1 thread, and then the 2 threads are allocated to C2 threads. Like this, it varies. And of course, you can set the compiler threads used by passing this system property. C1 compiler thread, say here I can specify the count as 8 or 10 or whatever number I can do, right? So this is how you'll go ahead and then you can configure the thread count, right? Okay. See friends, sometimes you may encounter the C1 or C2 compiler threads to be consuming high amount of CPU. So this is the core topic that we are planning to address in this conversation. Sometimes your C1 and C2 compiler threads may start to consume high CPU. When this happens, what are the potential solutions, right? So here I'm briefing like a 5-6 options, right? We will discuss them. See, the first one is what I'm recommending or what we are discussing, do nothing. That is, if you just see that there is a spike in CPU utilization for an intermittent period, and it's caused by a C1 or C2 compiler threads, then you may leave it aside, as long as it doesn't cause any outage, as long as it doesn't it doesn't consistently, these threads consume CPU, you may leave it, right? You can let it go because it is compiling, it needs CPU cycles. It's okay, it is acceptable. Okay. But let's say it is consistently consuming high CPU and it is kind of hurting your application performance. Then in that case, what you can do, there is this flag, the JVM argument called as -xx : tiered compilation. When you pass this minus tiered compilation, what will JVM will do is JVM will stop your C1 and C2 compiler from compiling or optimizing your code at runtime. It will stop doing that. When it stops doing that, then automatically the C1 and C2 threads will not be put in use. So then the CPU consumption, they will not consume CPU. But it may have a side effect. It has a potential to degrade your application performance because now the code that your developer writes is what gets executed as is, and which may not be optimal, right? It may not be performant. So that is a side effect, what you inherit, right? So the other possibility, the other solution is you can pass this JVM argument -xx tiered stop at level, and then here you can pass a level, right? So here if I'm going to say pass the level as 3, what does the 3 means is, that means I will only say, suppose you're only having a C2 thread, the C2 compiler threads are consuming ICP, right? When that happens, say suppose you're going to pass that level as 3, that means only the C1 compiler will be active. The only C1 compiler will be active. The C2 compiler thread will not even come into picture. So you'll not be invoking the C2 compiler. So you'll only take advantage of the client compiler taking effect. So your C2 threads will not consume CPU, right? So this is one possibility, right? But of course, that means the C2 compiler chain will not happen. It may also affect your application performance. You have to weigh in and then see what is your response time you have seen. And then the next option is you can pass this JVM argument -xx print compilation to your JVM. When you do that, then what will happen is the JVM will start to print what are all the methods, what are all the hotspot code which is being compiled. And this will be printed in your standard output stream or a standard error stream. That's where it's going to be printed. You will start seeing the log statement saying, oh, this is the method which is being compiled, and this is what is going on. So I'm not going to go into the detail of this one in this video clip. Maybe we have to make a separate video clip. So maybe you can look at that compilation metrics, and then you can see whether you can optimize that code which is being compiled, so that it will reduce the stress on the C1 and C2 compiler threads, right? So this is another possibility. And then the another solution, the potential possible solution is, see, earlier we saw there is a code cache, right? This is the code cache, is the region in the JVM memory, which is outside of your XMX and metaspace. That's where the compiled code by this compiler threads is the native code, what these threads compile is stored, right? By default, its default size is 240 MB. Maybe it may not be sufficient for an application. Maybe that can also trigger high CPU consumption. So what you can try doing is, you can try increasing this code cache size. Say here, we can pass this kind of an argument, XX reserved code cache size is equal to 512 MB. Right? You can pass like this, then increase your code cache size and see whether it is reducing your C1, C2 compiler threads CPU consumption, right? And then the next one, you can try looking at increasing your compiler thread count. Say maybe the default threads is not enough. Maybe you want to get more threads. You can look at doing it, right? When you do this, the compiler thread counts gets increased, right? So these are some of the potential solutions to address your C1, C2 compiler threads consuming high CPU. Okay, friends, do you guys have any questions?
Yes, Ram. It is good to know about the C1 and C2 compiler threads and how it will work, when it will invoke.
Okay, good. How about Ankita, Bhupati? What do you guys think? Is it
Yes, Ram, it's good to know about C1 and C2 compiler.
Okay, thank you guys.